On number 1, they want us to determine which table of values shows a linear function. So they're looking for the table that would yield a straight line. And to explain this to students, I would not go into slope, even though slope and rate of change is the basis of this problem. I would have them to focus right here. So on this line that is between x and y, and f of x is another notation for y. So between x and y, what is happening? So the first thing we have to do is figure out what is happening. Now, to get from 1 to 1, so if you input 1 and you get 1 out, you could really only multiply by 1. That's the only way to get that to work. 1 times 1 is 1. 2 times 1 is 2. So far, so good. But 3 times 1 is not 5. So 1 times 1 is 1. 2 times 1 is 2. But 3 times 1 is not 5. Nor is 4 times 1 going to equal 7. So because we have differences there, we don't have equals all the way down. This is not a linear function. Okay, on this one, again, have them to focus on what's happening between the towers. What's happening right here is what's going to tell us if it's a function. So to get from 2 to 1, you input 2, you get 1 out. You would have to divide, by 2. 2 divided by 2 is 1. So that dividing by 2 has to work all the way down. If it doesn't, it's not a linear function. Okay, so 2 divided by 2 is 1. That checks out. 4 divided by 2 is 2. 6 divided by 2 is not 5. 8 divided by 2 is not 7. So again, this is not a linear function. This one, again, we're looking at what's happening between the towers. And I have 7 to 4, so I would be subtracting 3. That's going to be fine. 8 minus 3 does not equal 6. 9 minus 3 does not equal 9. And 10 minus 3 does not equal 12. Another way, it just occurs to me that I've told students this before. This is from 7 to 4 is breaking down. From 8 to 6 is breaking down. From 9 to 9 is no change at all. There is no rate of change because there's no change. From 10 to 12 is building up. So that is also not a pattern of a function. This one, that would not work that way because all of them are breaking down in some form. They're just not breaking down at the same rate in each case. Okay, D, we have a couple of options on this one. And I would encourage students to look at them both because we don't really know which is which, and I'll show you what I mean. To get from 2 to 4, I could add 2 or multiply 2. From 4 to 6, I could add 2. So that tells me that this multiplying by 2 is not going to be helpful. So let's see if the plus 2 works in all cases. 2 plus 2 is 4. That checks. 4 plus 2 is 6. That checks. 6 plus 2 is 8. That checks. 8 plus 2 is 10. That checks. This is a linear function. because in each set of cells, left to right, the rate of change is the same. In each situation, I'm adding to the input. And you could even, if you want to write that rule, you are adding to the input. In the first three examples, I can't write the rule because the rule is not consistent down the cells. Okay, in this one, again, teach them to focus on what's happening in this space because that's the key to these input-output tables. They get focused on this and they're losing sight. The real stuff is happening in that purple space. So we could say 1 plus 3 is 4, or 1 times 4 is 4. Either of those. This is a building up situation. We could say 5 plus 4 is 9. There's no way to multiply this one. We could say 11 plus 3 is 14, or 15 plus 4 is 19. So you don't get a consistent rate of change in any of these. So this is not a linear function. Now the explanation for this one goes into actually calculating slope between each of those. That works. It's fine if you have students who understand slope, but I would approach this one with patterns. Help them to see the pattern that's occurring in those highlighted spaces, and they can usually pick out the one that, especially if it's linear, you can pick out the one that is that fits the pattern.